second step, we need to rewrite the CAPM to this equation. So if we consider from the cross-sectional aspect, so the cross-sectional aspect, which means you only consider the different stocks like 贵州茅台、五粮液、牧原股份, and we don't consider the time period. So you forget the time period now. So now let's have a look. The equation here changed to the left-hand side is our each individual stock's average return. So here, that's the each individual stock's average return, average access return, sorry. So average access return. And then for that is our Y. And for the X, big X, it is our each individual stock's beta. For each individual stock's beta is here. You have already calculated it. That is the new big X. So now let's run the new equation. The big X is our beta for each individual stocks, and big Y is our each individual stock's access return. Now we ran the new equation and got the slope and intercept, which is gamma 0 and gamma 1. Let's have a look at this gamma 0 and gamma 1. If capital SS pricing model success, the gamma 0 should equal to 0, and it should equal significant equal to 0. And if the capital SS pricing model success, you compare with these two equations, definitely this gamma 1 should significant equal to market access return. So the next one, we need to testing whether gamma 1 significant to market access return. If it is significant equal to market access return, definitely is the CAPM success. So when we're doing CAPM testing, we need to testing this two part. Now let's have calculated the gamma 0 and gamma 1. How can we do that? The first one, gamma 0 should equal to, remember, that's the intercept for this equation. So I can only use intercept, and then for Y, now in this cross-sectional data, the Y is each individual stock's access return, so we select this one. Okay, for X is beta, so we select the beta. So compare with different data, you know the time series is based on different time period, but for cross-sectional is based on different stocks. Now you finish that, you close bracket and press enter. So we got gamma 0 equal to 0.000663, and gamma 1 is equal to the same. Gamma 1 is the slope, so we type slope, and Y is here, and X is here. So that's the way how can we calculate this gamma 0 and gamma 1. And if you want to testing whether it is significant different from 0, we need to know the t statistic or the standard error. So in this case, only know the coefficient is not enough. So how can you do that? You can do it using other software, or you can directly using Excel. So for here in Excel, you click data. Have a look in the analyst part, we have add in solver, but we don't add in an analyst to package. So here we need another add-in. So you click file and the same option and add in, and here we click go. And here we click select Analyst 2 package and click OK. Now let's have a look here. In data right-hand side, we have the data analyst. Now let's change the data, our data to the column. So that's the our big X, and this is big Y. Now let's using the data analysis to do the regression. And now let's have a look for this regression. For the data analysis, you can select different analyst part. We use the regression, so we select regression, and there is a dialog come up. So for this dialog, let's have a look what we need to select. For the Y, we want to run the equation. For the Y is our each individual stock's access return, so we select this data. And for X is each individual stock's beta, so we select this column. And the output range, we can select any blank cell, and you want to output your result, and then you click OK. Now let's have a look. The result is coming up. So we have the coefficient for the intercept, which is gamma 0 is 0.000663. It's exactly the same as we use the intercept function. And for the X, the coefficient is the gamma 1 is 0.000435, so it's the same as we use the slope coefficient. And we have the standard error here. So we can use that. We know the t statistic. And based on this t statistic, we can do the analyst here. So it is let's have a look. It is for gamma 0 equal to 0, so we can compare this t statistic is less than the 2.7, so it is insignificant. So we cannot reject the null hypothesis. So this is success. And the second, we want to testing whether gamma 1 is equal to market access return, which is what is the market access return? The market access return is the last column here, right? So we calculate the average here, which is 0.000186. So now we need to testing whether gamma 1 is significant different from 0.000186. Now you need to use this coefficient. So I can directly type using this coefficient minus that market access return, and then you divide by the standard error. So we can divide by the standard error. The standard error is here. So we can select that, and then you press enter. So that's 0.57. So it's less than 2.7. So it is still insignificant. So we cannot reject the null hypothesis. So based on these two testing, we find CAPM succeed in our data time period. And also you can do other testing. For other testing, we can test because we know the if CAPM hold, we only have the beta to measure the systematic risk. If we include the nonlinear part, so we include beta square in our equation. If the gamma 2 is significant different from 0, which means CAPM doesn't hold. And we can also testing whether the unsystematic risk is significant different from 0. And if the gamma 3 is significant different from 0, it also means CAPM doesn't hold. So this this unsystematic risk is measured based on each individual stock's result. So you can run each individual stock's beta, and using the method as I mentioned, I will show you. You can run the data analysis regression, and now here for the time series regression. Now the Y part is, remember, Y is each individual stock's excess return. Sorry, get that wrong. So Y is our each individual stock excess return, and X is our market excess return. So you select market excess return. And then here, the data output range, we just give a new part like here. Give a new part like here. And we want to show the residual. So you can click residual and then you click OK. Now the result give it to you, and we can have a look. The beta for 牧原股份is 0.97, so it's exactly the same as we calculate based on the slope. And also, finally, I will show you. We give you the residual for each time period. So that's our epsilon I in the equation here, the epsilon I here. And if you want to calculate the variance for this epsilon, it's quite simple. You just type equal to VR variance, and you select all the residual, this column, and then press enter. So we get the result is here. So now you can just copy and paste this result here. So now you can write down this is your unsystematic risk. Okay, and you do the next one for 新希望 and etc. for all these 30 stocks, and you will get this unsystematic risk. And then you can run the equation for this new regression and get the result for gamma 0, gamma 1, gamma 2, gamma 3, and finally testing whether CAPM held. So that's the way how can we calculate each individual stock's beta and systematic risk, and also how can we do the cross-sectional testing for whether beta hold. So that's CAPM testing.